time here, I think we'll just probably have Philip just get started. But this is Dr. Philip Fanning from UMaine, and we're so excited to have you here today. Thanks so much, Phil.
Yeah, no, I'm delighted to be here. Again, I apologize about all of these technical difficulties. In my talk today, I kind of cover everything, but I've not covered anything in great detail. So hopefully after this snafu, you'll have me back. Cover some more stuff in greater detail. On my first slide, after my cover slide, I was just kind of talking about some of this cool research we were just setting up this morning. We caught sunrise over this big experiment that we're setting up to look at how wild blueberries might be impacted by climate change. And this is an ongoing trial we're setting up, and it looks at the ecosystem services that wild blueberries give to everything in terms of their surrounding area, including some of their bugs. So hopefully I can update you on this project in a future days. I said I'd quickly introduce myself, and I'm going to go through these slides pretty quick. But on the next slide, you're going to see a whole load of bugs. These are all the bugs that I've kind of covered and researched in my time as an entomologist. There's been a lot of cool work on chrysomelids and biocontrol agents and all of this fun stuff. When Hillary kicks next, you'll see, and maybe you're kind of gathering that I have a bit of an accent. So when it comes to my academic journey, I've done most of my research in Ireland, where I'm from. So I went to University College Cork and University College Dublin. I worked for an organization called Teagasc, which is an Irish word for information, so it's actually our extension service. Then I met my wife in Ireland, and she dragged me over kicking and screaming to the United States, and I ended up in Michigan State University as a postdoc. So I see myself as an entomologist, biology and ecology, the associated natural enemies of pest species. Growing up on a farm, I was very conscious of pests, and I always loved to, come up with really practical solutions and applied solutions. So I really kind of gravitated towards doing research on pests, but also thinking about how we protect pollinators. Again, that comes back to growing up on a farm and watching bees and all of that fun stuff in my youth. Okay, so the next slide is just meant to be a field of short rotation coppiced willow. This is where my PhD research came in. And you can see on the next slide, our main issue in Ireland in terms of this was we took willow, which was primarily found in riparian zones, and we moved it into, dense agricultural areas where they didn't have any of those natural enemies that we've probably heard in other talks and, enjoyed so much. And that led to a lot of defoliation, which kind of cued off a big issue and a need for a lot of research associated with that. So in addition to willow beetles, on the next slide, I was also working on a very cute beetle. I love the look of this beetle. It was not from Ireland, it was from away. In Ireland, we actually grow eucalyptus. It's mostly for cut foliage, so for flower arranging and stuff. And this little blighter came in on a big root ball of a tree fern that was brought in from Hobart in Australia. And that beetle started damaging all of our lovely cut foliage production. It was a completely undescribed species at the time. We later described it as Propsis turner salmani, but there was no information on its biology and life history. So that was part of my basically research as part of my PhD. On the next slide, you'll just see kind of some of the things I worked on. So we developed a temperature-based life history model. We modeled it across Europe. We really got in-depth information on the biology of the insect. And that was really key because on the next slide, you'll see what the the overall end goal of that research was. We wanted to introduce biological control. And I'm going to talk a little bit about my lab's efforts to do biological control here in Maine. But for this project in Ireland, prior to this leaf beetle, we had really good biocontrol agents for other invasives that had been introduced on eucalyptus. And crops as Turner so many really disrupted that integrated pest management program. So towards the end of my PhD, we started finally doing some work on Enagera reticulata, which is a classical biological control agent. We were also looking at nematodes in the soil and how we can increase their populations to control the pupae. So that's a quick, really brief introduction into some of my PhD research, so you can kind of get to know what I like to do in terms of my research into entomology. On the next slide, you should see a very cold site this is, I think, northern Michigan. These are not the blueberries we want. These are high bush blueberries or cultivated blueberries. But I did spend 3 years there as a postdoc working on a whole load of cool projects, again, focused on pest management, looking at a really cool little bug called blueberry stem gall wasp, which we do have in Maine, and we do notice in Maine's wild blueberry fields. And it's got a whole host of incline and parasitoid species that live within those galls. And we were investigating how to increase those to control this pest that had become problematic, primarily because of an invasive little vinegar fly that we're going to cover a little bit later in my talk. So that's kind of where I've gone. On the next slide, you'll see an amazing shot from the Blois in Maine of a wild blueberry. And this is where I spend most of my time now, chasing bugs around and really enjoying basically the outdoors here in Maine, which has been a fun place to get to know. So wild blueberries is kind of going to be the crux of my talk. One thing that I have found really fascinating about wild blueberries as a main crop is also the history associated with the entomological research that's come with it. So on the next slide, you'll see a really old picture from 1914 and 1915. And this is, you kind of got your typical, what you'd expect from a university setting back then. You got a whole load of guys. But the one person that will probably catch most people's eye is the woman in this picture, and that's Edith Patch, who really fascinates me as a researcher, but also somebody who's really interested in the history of entomology. So, we have a really rich history of entomology associated with wild blueberries. You can see on the right-hand side of this, we'll say, slide, a research report from the Maine Agricultural Experiment Station, which is now Maine Agricultural Forest Station, so Mayfies here in the University of Maine, back all the way to 1915. So we've been really studying this crop intensely. This report actually reports data all the way back as far as 1903, when Edith Patch first joined the experiment station here. So on the next slide, you'll see basically how Edith Patch was such a pioneer of entomology here in Maine. She created the entomology department at the University of Maine. There was entomological research happening before, we'll say, Edith Patch joined the experiment station, but she was charged with organizing our first entomology, which is really quite an achievement for when it happened and the time that it. I always encourage people to read this book, and hopefully, usually if we were doing this normally, I'd be asking people if anyone has read this book. But Without Benefit of Insects is a free book. It was probably one of the most detailed descriptions of the work and life of Edith Thatch. As an entomologist here in Maine, it was done by Cassie Gibbs, and it's just an amazing piece of work that's free for anyone to download from Digital Commons. So if you go on to the internet and look for University of Maine without benefit of insects, you should be able to find this book. For somebody who doesn't read, I actually read this cover to cover in one weekend. It was, such an enjoyable and rich history to get to know. Another fascinating thing about Edith is she was the first female president of ESA, and that happened in 1930. So, like quite a while ago. She wrote about 15 books. She had about 78 major articles. Her key area of research was aphids, and she had done a lot of work also on potatoes, but also on apples, looking at aphid populations. Some of this earlier research you can see in the next slide goes all the way back to 1918. There's a book here on the left-hand side by William Concord Woods that looked at sea beetle populations, and we still fight that little bug in wild blueberry today. But we have a really rich history again. The book on the right-hand side here, the report on the right-hand side, which I have sitting in front of me still, goes all the way back to 1922. And this is one of the main bodies of research that Edith Thatch done on blueberry maggot blight. And it was a fascinating piece of research way ahead of its time, and one that I still reference and still gets cited in many publications today. So some fascinating research. The next slide, I talk about another interesting entomological character, and that's Leo Bullinger. He again was also another entomologist here in Maine. He worked in wild blueberries, and I bring him up because he started some of the modern day pollinating insect surveys in wild blueberry. We still have his specimens sitting in the Maine Entomological collection that Charlene Dunn manages. So it's really cool to still have those bugs that he collected all the way back in the late 50s and early 60s that we can reference back to. Another fascinating thing is he was involved in formation of the Board of Pesticide and Control, which we all know is really important for us to be able to use insecticides in environmentally friendly manner. So he was involved in that, but also getting the university to have a sea grant proposal to bring agriculture. Again, deeply involved in the society, so the Entomological Society, but also the Acadian Society, Entomological Society. So we're coming forward in time on the next slide. Somebody who I'm not sure is on the call, but a really good, another pioneering entomologist in Dr. Frank Drummond, who I suspect some people might already know. I think I have a series of animations that hopefully Hillary can click through, but Frank has really ran the gap on all of the research he's done. So fruit flies and ants. He's also, in the next slide, you'll see all of the blueberry pollination work he's done, and he's really pioneered some of the pollination practices that we still run today in this crop. So we should be sitting back on my picture of flies at this point. I'm kind of going through this fast because I want to be conscious of your time. I know you stepped through all of those IT issues. Wild blueberries is a fascinating crop. If you go on to the next slide, you'll see, for anyone who doesn't know about this crop, it goes back way, way far back. So it goes all the way back 12,000 years ago, as the last ice age ended, and those glaciers receded. It was outwashed plains of very poor nutritional soil. Wild blueberries were one of the main things that colonized them. So if you click on, you'll see basically those outwash plains and all of the associated features associated with a glacial outwash plain. The key thing was those soils, wild blueberries were the key thing to move in there, and it gives us these lovely, really rich, in terms of diversity, heath communities that speckled through our entire state, especially in Washington County. You can see in the west on the next slide, Washington County has some of our biggest acreage. We used to have a lot more wild blueberries in Maine, and it was close to 120,000 acres of blueberry. Now down more around 42,000 acres of blueberry, but we produce more on those 42,000 acres because we've gotten really good at managing and cultivating that crop. It's still in a pretty sustainable manner. So it's more like a managed permaculture, which is really fascinating. So these are aerial views of the heath community or the blueberry barrens of down East Maine. But a lot of the communities of plants and insects that you would find in these areas, you'll also find all the way high up on some of our top mountains, as you can see in that picture that will pop up on the bottom left-hand side of your screen. Okay, so we see pictures of our blueberry barns, and that I think was in the winter. On the next slide, you'll see what my favorite time of the year is in blueberry barns. Like my two favorite times in blueberry barns. It's when bloom is, and then when we see a nice big carpet of blue blueberries, all covering these large areas. So to get to these lovely, voluptuous, nicely pollinated blueberries, we need a lot of insects. So really, you can't talk about the story of wild blueberries without talking about pollinating insects associated with it. Thinking about more of the history and the pioneers associated with, we'll say, pollination and entomology of this crop. Alison Dibble and Sarah Bushman have probably done some of the most extensive research and wrote some of the key papers associated with pollinators here in the state of Maine, but also pollinators associated with wild blueberry barns and this really cool crop. So in the state, we have 278 species across 37 genera and 6 families. In wild blueberries, I think we have close to 134 species have been found pollinating wild blueberries, but we'll go a little bit more into detail in that. On the next slide, you'll see my favorite kind of set of images associated with using SEM or electron microscope imaging. And this is actually of a wild blueberry flower. So on the top left, you see basically all of the parts of a flower. They've basically taken a blueberry flower and just cut a little bit of the corolla off. You can see the stigma and the stamen. Those anthers are really important, and they make wild blueberries really hard to pollinate. On the next slide, you'll see basically, or not on the next slide, on this slide, but in the picture on the top right-hand corner, you'll see basically what are really, really zoomed in image of pollen grains on the end of that stigma look like. So we know from studies we need 25 pollen grains to be deposited onto the stigma of each flower for those pollen grains to grow pollen tubes all the way down along there to produce basically a proper fruit and get decent fruit back. And again, insects are the ones that do all of that, which is really cool to think about. On the next slide, you'll just see some pictures of some of the insects that do it. So bumblebees, honeybees, we bring in, anywhere from 45 to even up to 60,000 colonies or hives of insects to pollinate wild blueberries every year. They basically help our supply be consistent. Our native bees are really efficient, they're better pollinators. But like any insect population, they have fluctuations in their populations that go up and down through time, which means that before we started using honeybees for pollination, our production and growers' incomes went up and down associated with pollination services that were being offered. And these insects do an amazing job. They'll see a little box pop up. Here's some real, like, back of the envelope calculations associated with just how many pollen grains get moved around by insects to pollinate a typical wild blueberry acre. So in general, when we've done counts, you can have about 35 stems per square foot. That will equal about 1,715 flowers per square foot. Then that means in the average acre, these are from pretty well producing fields, we'd have about 74 million flowers in that acre at peak bloom or throughout the entire bloom period. So when we apply that 25 pollen grains per flower, it means that about 1,850,000,000 pollen grains get moved around in every acre to realize ideal pollination. Now, we probably don't get ideal pollination every year. Weather plays a part. Our insects, whether they're flying associated with weather, etc. And then not all of that fruit or all those flowers will turn into a fruit just because crop can't hold all of those flowers and produce fruit out of it because they're limited by other factors. But definitely insects play a major part in this iconic crop and its yield associated with it. Okay, so thinking about the diversity of bees, on the next slide, you'll see basically what type of, bees or the amount of bees we find in wild blueberry fields. So we found more than 133 species of bees in Maine lobish blueberry. We get bumblebees, we get leafcutter bees and mason bees. The andrenids are really good. So the sand bees are really key species. They're a spring bee, and they link up really well with the activity of our crop. Sweat bees, I know that Jen Lund recently gave a talk and really went into details on all of these groups of bees. But sweat bees, plaster bees, and digger bees, again, they're all amazing diversity of insects associated with this crop. Now, we don't find all 133 species in the same field. Most fields will have about 5 to 40 species, depending on the size of the field, the management associated with the field. There's a lot associated with what drives the diversity of insects. But smaller fields can really have quite a good population of these native pollinating insects. One really cool study that you'll see in the next slide is from another former speaker, Patty Jones. Her student Rachel recently did a study which fascinated me when I reviewed it. Geeked out quite a lot on this. But we think about bees, and I kind of sold bees as the key pollinator. But what they did in this study is they actually looked at nocturnal population or pollination of wild blueberries. And they actually found that when they bagged wild blueberry flowers, and some were open during the day, some were never open, some were only open at night, they had a series of controls, they found that they got adequate pollination to produce crop in those flowers that were only open at night. So this was in a small island off, we'll say, the coast of actual Canada. where I know Patty does some of her research, but it was a really cool example that, bees are pollinating this crop, but also there are other nocturnal pollinators associated with the crop as well, especially in these wilder areas. I'm not sure how good that translates into some of those bigger wild blueberry barns, but again, it's just fascinating to think that we have these nocturnal pollinators to pollinate them. You're going to see the annual associated with wild blueberry. And like anything, like any commercial crop, we're kind of going to focus in a little bit on some of the pest species that we deal with in the crop. A lot of these species are ones that have been studied all the way back 100 years ago, but still become problematic. But there's also some invasive insects. We all kind of are very conscious about invasive insects these days. We know that global trade is speeding up the introduction of invasive insects. And one thing my lab is trying to do is to battle some of these invasive insects. So, some of the other bugs that we see on the next slide, even if you have a small blueberry patch, next to your house, or you've noticed some wild blueberries sitting along a road, you might be able to spot some of these other blueberries. Blueberry tip midge is a very small little bug that causes these leaves, as you can see in the picture on the left-hand side, to curl. So they curl those leaves, and they cause the tip of the leaf basically to be curled into a gall for them. Now, I know you recently had Esteban from the University of New Hampshire. I'm actually working with Esteban and his student to sample some of the parasitoids associated with this species in wild blueberry fields here in Maine. He's got really fascinating data, him and his students, on some of the bugs that are attacking this blueberry tip midge within Maine wild blueberry fields. For the most part, that bug really doesn't bother us too much. You can see big areas of some years where you have a whole load of these galls, but they rarely get to a level where we'd have economic damage. But we are kind of in the same boat. They are, some years they get really big, and the strips basically again roll leaves, but they don't just work on the tip, they'll produce a whole load of leaves and get them all mixed together. And again, this is another one where we can go into a field and see kind of a clone, or we say one of the plants really impacted by these little strips. But for the most part, they're not really an economically damaging insect. We have two species that really impact us here in Maine. Again, this is just another one you might see, but it's not a big problem. On the next slide, you'll see probably two that are really loving our mild winters these last 3 years, at least. That's how long I've been here. The winters have felt pretty mild from all the scare stories that people told me before moving to Maine. But blueberry spanworm and blueberry flea beetle, these can be pretty problematic. You can see pictures on the right-hand side of the levels of defoliation they can get up to. In the crop year, they'll eat your fruit buds, they'll eat all your leaves, they'll eat your flowers, so you won't have a crop in that area. If it is in the prune year, so we prune the fields to increase their vigor. So if you pruned your field, the next thing an infestation of these little blighters come in, they will stop your crop from emerging when it normally needs to emerge or has to emerge. But it can really impact how quick your crop grows within that year. where your leaves and your stems grow within that year. And then that impacts the amount of fruit buds that those plants can put on for the next year. So they'll also impact that crop the following year. So these are two bugs we deal with quite a lot. Again, some of the history of entomology that I pointed to, all the way back in 1918, they were still working on these bugs. So entomologists, especially those working with ag pests or any pest of economically important products or crops or forestry or anything, is we need to have a lot of patience with our work in these insects. On the next slide, you'll see a meta-analysis, or at least one image from a meta-analysis that was done on blueberry IPM. So IPM, again, is integrated pest management. And they were looking at basically what were the key pests over time. So there was a lot of others, and I think we covered some of those others. On the left-hand side of that pie chart, you'll see a big orange, we'll say, slice of the pie. That's blueberry maggot fly. It's a tip-ridded fruit fly, which can be pretty problematic for our growers. They lay their eggs into our fruit. Excuse me. And then those larvae will develop in the fruit, and they can really impact the quality and the amount of fruit that our growers can pick. Above that is a new little bug that's from away that is what my lab has been working on a lot. And it's called spotted wing Drosophila. But the key thing to take home here is like direct fruit pests or frugivores really dominate blueberry entomology, and we'll say a lot of the historical work, the current work that's ongoing for good reason. Obviously, people want bugs in their fruit, so that's kind of where we're focused. So on the next slide, you'll see basically there's been a lot of really good, rich work that's been done into the entomology associated with blueberry maggot fly, a lot of entomology research. Posted in one graph and a picture from some of the work of Frank Drummond, again, and Judy Collins, and through decades of careful work, even going back to Edith Patch, we've learned quite a lot about the biology and the ecology of these blueberry maggot fly, where we've come up with some really good sustainable management to control this pest. And they're all focuses around controlling it at the perimeter. This is what we call a perimeter active insect, where it really spends a lot of its time hanging out at the edge of the crop. So we've been able to develop really good targeted insecticide applications, attract this bug to it, so we don't have to spray as much. We can spray less potent insecticides because we've done the research, and we only spray perimeters, which is a really good way to control this bug without increasing costs for growers, but also just spraying insecticides when we don't need to spray them because we're targeting where that bug is. Okay, so that was kind of a quick go through of some of the blueberry insects that we deal with. On the next slide, you're going to see it's kind of like an acknowledgement slide. It's right here in the middle of this talk. Not quite in the middle, it's not true. But you see my current lab. So you see it in the top picture. You'll see Shanaz, who's a new master's student. Judy Collins, who's both in the top picture and the bottom picture, has been working with wild blueberries and entomology ever since she finished her master's here at the University of Maine 37 years ago now. So she's, again, one of those pioneering entomologists that has done a lot of work associated with this crop. I don't think there's anything she doesn't know. All of the bugs I just talked about. But we received a lot of funding from the Wild Blueberry Commission and the USDA to work on the bug we're going to talk about in the next slide. So you can see some new bugs to Maine. And this covers that little insect pest that I was recently just talking about in that pie chart. This is spotted wing Drosophila. It's different from all of the other Drosophilids that we commonly have in our house. If we bought some bananas and we left them out on the counter too long, we get some fruit flies, and they're usually just Drosophila melanogaster. This little invasive bug came in from Asia. It was first detected in California in 2008. And it has the ability to basically saw into fruit with this serrated ovipositor that you'll see in the picture at the bottom, and lay its eggs into marketable fruit. So we call it spotted wing Drosophila because those males have those dots in their wings. But this little blighter has really caused a lot of troubles across the entire world at this point. It came from 10 native countries, and it's now distributed in 52 countries across the world, all in basically a 20-year period. So it's been a significant test, and the predecessor Frank was working on it when he started, or when he first discovered it here. Where I started in the University of Maine, I've continued some of that research. So we've been doing a lot of sampling. We do this test called salt flotation test, but we also use baited traps to trap these insects. On the next slide, you'll see basically all of the samples that we collected in one day last year. And that's my graduate student, Ben Johnson. I think he was smiling, but I don't know how happy he was, because we were facing into going through all those samples, and we were going to put in a strong salt solution to float out any larvae that was in that fruit. But that research is all focused on understanding that biology and ecology of this new bug. So, like I said, we finally got good control for blueberry maggot fly after probably close to, 100 years of research. We're hoping to get it a little bit faster with this bug, but we're not making any promises. But Ben has been working a lot on understanding that, that ecology of this bug in wild blueberries. You'll see in the next slide, it has a really strong perimeter behavior, which we're fascinated to find. This is new research we've done over the last 3 years. We are finding that spotted wing Drosophila is very much mimicking the behavior of our native frugivore blueberry maggot fly. And I worked in Michigan, and I've worked with people across the entire country on this bug. And only in Maine does it behave in this perimeter perimeter-driven behavior as strongly as it does here in Maine wild blueberry, which is great for us because, again, we can go towards doing more sustainable control for this bug, not have to face or use quite a lot of insecticides for its management. So a lot of the infestation happens at the border, and that's where we can focus our energies. Okay, so I wasn't going to bore you with a lot of research on insecticides, and I know we're really coming up on time for when we were meant to finish. Again, sorry for the late delay. But a large focus, and a lot of this work was led by Kent Dane in UC Berkeley, who my lab collaborates with. But there's been a real concerted effort over the last number of years to find biological control options to control the spotted wing Drosophila. obviously a biological based, we'll say, solution for this invasive insect. It is environmentally friendly. It is economically, we'll say, important. So growers aren't spending monies on inputs to control this bug. We're hoping that we can get the other bugs to attack it. We started by looking at all of our native resident parasitoids to see basically how well they deal with controlling this invasive vinegar fly, spotted-winged Drosophila. We looked at pupal parasitoids, but also larval parasitoids. On the center picture and the left-hand picture of the slide, you'll see Placioploides in the mirror and Trichopia drosophilina. These are two pupal parasitoids. They can actually attack spotted-winged Drosophila. But what we found, and we've done lots of trials, we've mass-reared them and then augmentorium work. We just naturally, try to encourage them at sites. But really, we only get about 0 to 10% parasitism. So not enough to keep up with the biology of, we'll say, spotted-winged Drosophila. The little bug itself has a really high fecundity and it can attack, we'll say, crops really well. On the right-hand side, you see one of our larval parasitoids, Leptopolina. It's probably Leptopolina heterotoma. These are specialized to attack Drosophila melanogaster. We found that basically they're completely ineffective against spotted-winged Drosophila. On the next slide, you'll basically see why. So because they haven't co-evolved with spotted-winged Drosophila, spotted-winged Drosophila is able to encapsulate the eggs and larvae of all of our resident larval parasitoids. So they were not effective. What we'd find these spots. You can see on the bottom picture here, you see this black spot on the abdomen of the fly. That is basically where one of our native larval parasitoids has encapsulated larvae from one of these parasitoids. Okay. So we very much felt like classical biological control was needed. So this is where we go out and we search for other bugs. You can see the picture, and I'm kind of showing my hands here. You see we can find a bug, but on the next slide, you'll see that some of the pictures of foreign exploration. So classical biocontrol, foreign explorations were ran in Korea and China in 2013 and 2017. They found a number of different candidates. On the next slide, you'll see basically they reared up 19 parasitoid species in these foreign explorations. And 3 of them look promising based on, some of the preliminary data that was found in the field. We'll say in Asia, in SWD's home areas. They were brought back basically into quarantine in the United States in Kent's lab in USDA lab in Delaware, where a lot of research was done to ensure that these were friendly, good. There wouldn't be a lot of non-target impacts. They were very specific on our target bug, which was spotted-winged Drosophila. The key part of that is looking at host specificity testing. And you'll see on the next slide some of the results of that host specificity testing. So we had 3 bugs we brought back. We had Acebara, we had Leptopolina japonica, and we had Ganaspis brasiliensis. One key thing here is you'll see all of the SWD or the spotted Drosophila species on the left-hand side, where you see big gray bars that go all the way out. That means that they were successfully able to attack that Drosophila species and parasitize it. Obviously, the example on the left is the Acebara, broad host range. And we said we're not going to try and release that in the United States. It would attack a lot of our native Drosophilids, and it's really not what biocontrol is meant to be. The Polina in the middle also was attacked too many of our native Drosophilids, so that was excluded and it wasn't released. In Aspis brasiliensis, one key thing here is we actually had two strains of Aspis brasiliensis. This is the G3 strain that attacked Drosophila melanogaster, Drosophila sinulans, and Drosophila suzukii. But we also had a G1 strain, and in all of the tests we did, it only attacked Drosophila suzukii, so our target bug that we didn't want attacking our crop. And that's the one we eventually got. Permits to release. It wasn't a small undertaking. So foreign explorations went on for 4 years. There was multiple years of lab work to get all of that data, and this graph was the key graph. But on the next slide, you'll see some of the regulatory hurdles. And for brevity, I'm not going to go into this much, but Hillary will be able to flick through it. There's multiple federal actions triggered when you want to release a biological control agent. It's basically what our group went through to try and test out this little bug to control spotted Drosophila in the field. It goes through the Endangered Species Act, the National Policy Act. It gets reviewed at multiple levels, so we do all of the host specificity, like I said, economic and environmental impacts taken in, and pre-release surveys and post-release monitoring are all needed. It goes through a lot of consultancy, so NAPO is involved, the North American Plant Protection Organization. It goes through tribal consultation, and it goes through a public consultation before you get, or you hope to get, what we call a FONSI, or a finding of no significant impact. And for Aspis brasiliensis G1, we did find that there was no significant impact, which was great. And that meant, on the next slide, you'll see we were granted permission to release this bug in fall of 2021. Just started in about 2010, about 11 years after we started thinking about needing classical biological control for this bug, and we finally got the permits to release it. Now, here in Maine, we got our I's and crossed our T's a little bit more, and I worked with the Maine Department of Inland Fisheries and Wildlife. They reviewed all of that data again to make a Maine-based decision on this. They concurred with a finding at the federal level, so we got a Maine-based permit to release it as well. Okay, so we're excited by all this, and we drove down to our lab in Delaware and picked up basically a colony of these wee little wasps. So on the next slide, you should see progress on classical biological control. So we established our colony in February of 2022 from the USDA APHIS, and we bulk reared it all of last year, all of last spring, and early summer in our lab. Now, I usually try to emphasize the size of these wee bugs. So, you know what a fruit fly is. These are smaller than a fruit fly. So when I say little parasitic wasps, I really do mean that they're doty wee things. You can see on the left-hand side picture, there's a little vial. In there, you see a little piece of paper that's actually stuck in with an entomological pin. I think it's a 0 pin, so a pin is really small. You can see all those black dots. And that is basically these little parasitic wasps that we're sending out to try and fight the good fight and control this invasive insects. So, in the next slide, you'll see basically how we did our experiments last year. We basically did pre-release sampling. We did this at 4 sites. We focused it on organic and untreated sites, just in case insecticide might have impacted the little bugs we were releasing. And over a 3-week period at each of these sites, we released 400 adults every week. So a total of 1,200 adults per site. And then we did post-release sampling associated with that. Now, on the right-hand side of this, you'll see kind of a little white delta track that we used. And you'll see all of the little parasitic wasps that were crawling out and taking flight, heading off into the great unknown. Okay, so our results from our 2022 sampling, we didn't find any parasitoids in our pre-release samples. And it was possibly because they were done a little bit early. We know, I saw this in my research in Michigan, that really these Drosophila parasitoids only ramp up when Drosophila populations themselves ramp up late on in the season. In our post-release samples, we did recover Drosophila parasitoids, so we knew that these were parasitoids that had parasitized Drosophila. We isolated them, and we recovered 2 species. So we were really surprised by this, and we quickly went back and made sure our colony was the species we intended to release, Ganaspis brasiliensis, but we actually recovered Ganaspis brasiliensis and Leptoplina japonica. And these samples have been ID'd and they've been confirmed with DNA barcoding, but it seems that Leptoplina japonica has actually found its way here from Asia, much like spotted-winged Drosophila found its way from Asia, and it's kind of restoring the balance all by itself. In the next slide, we come back towards those host specificity trials that were ran. And again, you'll see Ganaspis in the red circle. It was really quite a host specific one. And again, this is G3 strain. We released the G1, which was even better again. You'll see Leptoplina, it attacks more Drosophila species than we'd be comfortable with as biocontrol. But now that it's here, its populations will probably build and grow because it has that broader host range. Now, we weren't alone. You'll see on the next slide, you should see sampling results from basically across the country. And all of the states in red here found Leptoplina japonica either last year or this year. So it seems like we had multiple introductions. It has quickly spread, much like spotted-winged Drosophila is able to spread up and down the east coast. It's been found on the west coast. You basically see it's been found in Europe. It found its way to Europe all of a sudden. It found its way into Washington, and it found its way into Canada, Vancouver, or in British Columbia, all within a couple of years. So I know Hillary is well aware of how this can happen. She did it for her PhD with Trisophis japonica and brown marmorated stink bug. So sometimes these biocontrol agents can just find their way here by themselves. Okay, on the next slide, you'll just see basically some data from Asia where they were sampled. They focused on these 4 species, 2 of rubus, 1 wild strawberry, and an elderberry or sambucus. And really what this is take home is Ganaspis and Leptoplina actually work really well together. They can be very good at targeting and controlling spotted-winged Drosophila. So while we're going to continue releasing Ganaspis, Leptoplina is likely going to spread, increase its populations, and together they really might control this invasive bug that we don't want to deal with, or we don't want our growers to have to suffer through dealing with. On the next slide, you'll see basically our what's next. So we're currently looking at overwintering trials, and Shanaz in my lab is leading that work to see if Ganaspis brasiliensis will overwinter here. We're looking at augmentoriums. So these are little tents that will allow us to increase the populations. We're going to do more releases, and I'm excited we're going to get to collaborate with Hillary on these. Me and Hillary are going to start working together to do more releases, but also monitor the spread of that surprise bug that we now can confirm is in this stage. Kind of some of the research we're going to be doing moving forward. I think that's my last slide. Yep. The next one says, thanks. I'll take any questions, and hopefully this weird technology situation, we'll be able to do some questions if you have.
That was great, Phil. I think it worked. I think people could hear. Let's see what we got going in the chat here. Kathy Murray asked, might the perimeter pesticide treatments affect survival and effectiveness of Ganapsis?
Thanks. One key thing about spotted Drosophila is that a huge host range. A lot of the population actually builds up outside of our crop, and not even at the edge of our crop. It's deep in the woods, and some of the other fruits early in the spring. That's where spotted Drosophila builds up its numbers, and then it moves into the crop. So we're hoping that Ganapsis will be out there in the woodlots and in and around our fields doing its work before it even moves into our crop. So there is potential, but hopefully Ganapsis won't be even needing to get into our crop anymore, because it'll be targeting spotted Drosophila outside our.
Great. The other Kathy Murray with the C says, thanks for overcoming the technical difficulties. Really interesting.
Sorry again, this is embarrassing. I don't know why it didn't work, but we gotta get to see it again, and we can have more interaction.
Did anyone that's still here, did anyone want to pop on, ask any other questions?
Sure. This is one of the Kathy Murrays again. Great talk. I really learned so much. That was really wonderful, and you really did overcome the challenges of technicalities. So what was my question? Oh, so I think you showed that Leptopolina could have as much as 20%. 20% parasitism rates. Is that enough to actually really reduce the population enough to protect the blueberry crops, or is that just not enough parasitism too? You know what I mean? It will be a significant factor in reducing, in protecting blueberry crops.
Yeah, so I think one key thing is, I think it might push back when we see this massive population spike that we get every year. So currently our populations start off really low. We found that our milder winters, this is of spotted Drosophila, our milder winters have brought that forward a little bit. But currently our populations really only build up as we're starting to harvest wild blueberries. My hope would be that earlier in the season, that Ganapsis and the Leptopolina are going to reduce some of the surviving spotted Drosophila that have made it through the winter, so that population doesn't get a chance to grow as early as it used to. I think even if we pushed back spotted Drosophila's, large increase that we get by a couple of weeks, or maybe 3 or 4 weeks, that would be really impactful for wild blueberry growers to harvest their crop without having to really deal with the large population numbers late in the season. So it's probably not going to keep up with the sheer, biology of spotted Drosophila, but it might slow them down sufficiently. Yeah.
Great. Kathy Murray asks, Kathy Murray with a C. I don't know if you know we have 2 Kathy Murrays. What are some likely unintended consequences of the L. japonica due to attacking other native Drosophila?
Yeah, that's yet to be seen. It'll definitely build up its populations also on Drosophila melanogaster. I've given or talked with multiple other folk about this, and they said, well, we don't need that one either. But we really don't know what might be the unintended consequences. In terms of the consequences for, let's say, our other parasitoid, you really actually think they'll synergize together, and they'll actually work pretty well together. We don't think it'll have any impacts on our biocontrol, but it might be attacking some of the other Drosophilids that we have here.
So, Phil, I don't know as you know that there's a bill before the legislature to make the, this is Charlene Donahue, the pink-edged sulfur, the Maine state butterfly. And the pink-edged sulfur feeds on blueberry leaves, a little bit in the fall and then again in the spring. So is treating chemically for spotted winged Drosophila potentially going to affect these populations? You know, if you have to treat in the fall?
Yeah, I'm not sure on that. You know, if that, we'll say, butterfly is usually active in and around, or we'll say are more managed wild blueberry fields. But certainly if pesticides were being used, again, depending on, we'll say, the phenology of the butterfly overlapping with some of that management, it's not beyond the realms of possibility. But I really don't know much about the butterfly's phenology to make a really confirmatory statement there. Yeah.
Great. I think that no other questions in the chat. Hey, the workaround seemed to work. So.
But also everyone who attends for your patience with the whole scenario.
And I will make a plug. I did put this in the weekly forewing, but I'm going to be looking for someone who wants to work for me with this project. So get the word out if folks know of anyone that might be interested. So
cool.
Great. Well, thank you, Phil.
Right. Thanks, Hillary. Thanks for holding that phone all this time.
You've been resting on a tissue box. You're getting lots of thank yous, so we really appreciate you coming, and have a
I look
wonderful.
forward to seeing you all in person some events soon.
Yes, maybe you can come out to one of our field days this summer.
Yeah, we love it.
All righty, catch you later. See you later, everybody.
Bye, everybody. Thanks.
Bye.